everyone, and welcome to your lecture series on measures of association. Moving forward. Yep. Yeah, all good. All right. So in this lecture, we'll be covering measures of association. Particularly, we'll be covering measures of association where you can understand how to quantify association for cohort studies and versus case control cross-sectional studies. Basically, what do I mean by this is, firstly, what are cohort studies? Cohort studies are, for example, your prospective cohort studies or longitudinal studies, meaning you are following the participants for some period of time. Alright, so it could be for a couple of weeks, or it could be for a couple of months, or it could be for a couple of years. Alright, so you have the opportunity to follow participants for some amount of period of time. When you are looking at such studies, that is when you quantify associations using risk ratios and attributable risk. And we will study how to quantify associations using risk ratios and attributable risk. And when I talk about associations, what do I mean? I mean when you are quantifying the relationship between your independent and your dependent variable. All right. Similarly, when you are looking at cross-sectional studies, what is cross-sectional study? In prospective cohort study, longitudinal study, you were following people for a period of time. Cross-sectional study, you are just looking at people in one snapshot. Alright, you are not following them up for number of days, number of weeks, no, just one snapshot and that's about it. Okay, so just one time point period, that is your cross-sectional study. What is case control study? You have two groups, minimum of two groups. One is case, meaning, for example, these people already have cancer. The other one is control, they do not have cancer, and then you are studying both of these groups. Okay, case versus control. All right, case control studies. So when you have such studies, that the way you quantify association between your independent and dependent variable, that is using odds ratios. Okay, why is this important? Why is all of this information so important? Again, guys, yes, very important for you to understand research articles and reports, so on and so forth. Understand statements such as individuals smoking are 4 times more likely to develop cancer versus individuals who are not smoking, things like that. But again, as I said, that it is becoming very, very important for students not just to graduate with the basic competencies of placements at the end, community, clinical and food service, but the job market is demanding that you have your X factor, which I have spoken about a couple of times previously, and that is why having say clinical skills, research skills will be important for you to demonstrate in your job interviews that you can give more to this job than just what is there in the position description. All right, and a lot of jobs love it when you come with a complete skill package, and more jobs are demanding you to have research skills, because a lot of sectors, be it clinical sector or be it community sector, they do their clinical work, they do their community work, but within that they are also doing research, and if you come up with such a package, you have a value added advantage over the other candidates. Okay, so that's why this sort of information you are learning and why it is important for you to prepare you for real life opportunities. Alright, so just like a previous time, if possible, please do look at both of these YouTube videos. Most of my readings, as you have seen, they are not complicated research articles which you may not have the time capacity or the understanding to comprehend them at this stage. But when you look at interactive videos which are educational, this would help you with your learning as well. Alright, so please do look at these videos before you proceed further in the lecture. Alright. Okay, so what is our basic aim of today's lecture? To understand association between independent and dependent variable. So for example, your independent variable could be smoking, and you say that smoking is associated to cancer. smoking can cause cancer, smoking is related to cancer. Alright, but how do you understand association in the world of epidemiology, in the world of statistics? By quantifying them. Alright, you need to put numbers to the association of smoking and cancer, and therefore today's lecture. Alright, so yes, as I said that for cohort studies, the way you quantify associations between your IV and your DV, which is your independent and dependent variable, that is using risk ratios and attributable risk, versus when you are quantifying association for case control studies, cross-sectional studies, you use odds ratios as your test statistics. Okay. Alright, and one more very important thing, guys, why don't we calculate risk ratios for cross-sectional studies and case control studies as well? Basically, guys, when you have prospective cohort studies, longitudinal studies, you can compute true incidence from these studies, because basically when do you calculate risk ratios? When you follow people for a prolonged period of time and then they develop the health condition of your interest during the time of your study, meaning you followed people for 10 years and they developed cancer, or they developed cardiovascular disease, or they developed type 2 diabetes. So you can calculate the true incidence rate from prospective cohort studies, and only when you can compute true incidence rate, that is when you can calculate risk ratios. In your cross-sectional studies, case control studies, you cannot calculate true incidence rate. Alright, meaning in case control studies, you are already looking at people with cancer. It's not that they have developed cancer after 10 years or within the time frame of your study. They are already having cancer, and then you are comparing them with people who do not have cancer, and then you may be doing something with your study, or else people who are already smoking and people who do not smoke, and then you are doing something with your study. Alright, so over here you cannot calculate true incidence rate, and in cross-sectional studies they are even weaker. In cross-sectional studies you just have one group. You either look at people with cancer and you study them for their smoking habits, but you don't have any control group. Alright, so in cross-sectional study just one group of people, no control group, and that one group of people that you are studying, they are all having your health condition of your interest, which is say cancer, or they are smoking, something like that. Alright, so when you cannot calculate true incidence rate, that is when you calculate odds ratio. When you can calculate true incidence rate, you calculate risk ratios and or attributable risk. So I hope that is meaningful, guys, as to why we have two different calculation which depends upon the type of the study design. Alright. Okay, so now the first one which we'll look at is your risk ratio and attributable risk. Remember, you're calculating them for prospective cohort studies where you can actually compute your true incidence rate. Okay, so moving further. Alright. So risk ratio is also called as relative risk, and what is the say definition of it? A risk ratio is also called as relative risk, and it compares the risk of a health event of your interest among one group with the risk of the same health event among the other group. Alright, the formula for risk ratio is very simple. So what is IR in the formula? So in this, IR stands for incidence risk. And now when I say incidence over here, I mean true incidence. Alright, that thing happened during your study. Okay, then you have E is the exposed group, and you have U, which is the unexposed group. Risk ratios, when they are expressed in terms of ratios, one meaning the risk of something is equal in two groups, greater than 1 risk is more in the exposed group, less than 1 risk is less in the exposed group. You can also express your risk ratios, attributable risk, as percentage, one compared to the other, and we'll look at that. So let's look at this example. So you have 75 people who went to the church on Saturday, and you have 60 people who went to the church on Sunday. People from the 75 people who went to the church on Saturday, 20 of them got food poisoning. Alright, so yes, 20 of them got food poisoning, 55 of them did not get food poisoning. 60 people went to church on Sunday, from them 5 of them got food poisoning and 55 of them did not get food poisoning. Okay, so now the calculation, the formula is very simple, which is your IRE divided by your IRU. So your risk ratio for the Saturday is your 20, which is, yes, they are exposed, okay, that is your IRE 20, okay, divided by your IRU, the total number of sample, okay, and then you divide it, this is the number you get, you multiply it, you have 27%, okay. So that is your risk ratio for Saturday, alright. What is your risk ratio for Sunday? Same thing, that's why it's color coded, which is 5 divided by 60, you have 8%. And now what is the formula, which is IRE divided by your IRU, okay. So what is your IRE divided by your IRU? This is your exposed group to your unexposed group. You divide both of these, this is the number which you get, 3.4%. The risk of food poisoning was 3.4 times higher among people attending church on Saturday in comparison to Sunday. Okay, does that make sense? So it's very simple. Of course, this example is so simple, just by looking at the numbers you know that the risk of food poisoning is higher for people who are attending the church on Saturday. Alright, but I hope this is meaningful and it makes sense. Risk ratio is basically you have your incidence rate exposed divided by your incidence rate for unexposed, okay, and this is how you substitute the numbers and you get your answer, okay. So with risk ratios, guys, you use the term times, okay. So whenever in research papers it says this group had so many times higher risk of something compared to the other group, times generally refers to risk ratios. If you have research papers which says the odds of somebody hit by a motor vehicle is 4 times more than the odds of somebody, say, dying because of drowning, when you use the term odds, they are referring to odds ratio, okay. So you use the term times in risk ratios, okay. So that is how technically you should be using it correctly. There are some people who interchange risk and odds ratio, the terminology, but that shouldn't be done, okay. So I hope this is clear, guys. So this is how we express risk ratio, where the risk of food poisoning was 3.4 times higher in the Saturday group versus the Sunday group, okay. Alright, so now you have risk difference or rate difference or attributable risk. So yes, different names, but yes, the most popular one which you will find in research papers is attributable risk, but some of the papers may report the same thing as risk difference or rate difference as well. Alright, so over here it's the same concept, which is attributable risk is the difference between the incidence of disease in the exposed population versus incidence in the unexposed population. So you have that is same, which is IRE and IRU are the same, but look at the term, it's the difference between, okay. So therefore you have a subtraction. Previously you had a division, alright, here you have a subtraction, okay. So your attributable risk is where your population of exposure, the difference between your population of exposure versus your unexposed population, okay. Then attributable risk, what it does is that it gives you a strength of association, okay. It explains to you what is the strength of association, say between your IV and your DV, okay. Is the strength of association good, bad, what is it? So just as an example, and this is how it's written in, like, you know, research papers. For example, in study 1 showed that the attributable risk for cigarette smoking and lung cancer was 85%. What does this mean? It means that 85% of the lung cancers are attributed to, and attributed, the meaning of the word attributed is caused by cigarette smoking, okay. So that is what it means, meaning in that study, in that population which the author studied, in that particular population, lung cancer was occurring predominantly because of cigarette smoking, 85% of it. Okay, so that's a very, very big variance which is explained by cigarette smoking. Okay, the other percentage, it could be explained by something else. Lung cancer could be because of something else, environmental pollutants, who knows. Okay, genetics, whatnot. All right, but 85% of lung cancer in study 1 was because of cigarette smoking. Okay, so it shows you the strength of the association between your IV and your DV, your IV being your cigarette smoking and that being lung cancer. All right, then you have your study 2. So what is study 2? In study 2, it shows that the attributable risk for cigarette smoking and lung cancer was only 15%, meaning 15% of the lung cancer in that study are attributed to cigarette smoking, meaning the remaining amount of percentage, that is happening because of something else. Okay, so it could be because of other things, as I said, environmental pollutants, so on and so forth. So what does this show? This shows that the cause of lung cancer, which is smoking, is much more stronger in study 1 in comparison to study 2. Does that make sense? So that is why smoking as a cause of lung cancer is a very big thing in study 1, strength of association, versus it is not the biggest cause in study 2, because the population are different, the population where they are living, the characteristics, so many things are different. But this is what attributable risk does. It gives you an indication of the strength of the association. The formula is very, very simple. Again, IR is the incidence risk. You have your exposed group and then you have your unexposed group. Okay, so it's the same thing, guys, which is, it's the same example. 75 people visit the church on a Saturday, 20 of them get food poisoning. 60 people visit the church on Sunday, 5 of them get food poisoning. You have a different sign. This time you do not have a division sign. You do the exact same thing, 20 divided by 75, 5 divided by 60. This is what you get. This time you minus them out because attributable risk is the difference between your exposure and your unexposed group. And what you have is 19%. What does this mean? It means that 19% of the disease risk, which was what is our risk, food poisoning. 19% of the risk of food poisoning could be attributed to people attending the church on Saturday in comparison to Sunday. So 19%, yes, people who got food poisoning on Saturday, unfortunately, the strength of association between food poisoning and attending the church on a particular day is 19%. All right, meaning it is not a very, very strong number. All right, so if it was say something like 90%, 85%, oh yes, that's a very strong association between your IV and your DV. Over here, there could be other reasons of food poisoning that needs to be explored apart from people attending church on a particular day and getting food poisoning. All right, so this tells you the strength of the association between your IV and your DV. Okay, so I hope this is clear, guys. Attributable risk. Alright, now moving on to odds ratio. Remember, odds ratio is something which you will predominantly find in your case control studies, cross-sectional studies, and you calculate odds ratio when you cannot calculate the true incidence. You are already studying people with that disease condition. Okay, calculation of odds ratio is very simple, and guys, again re-emphasizing, odds ratios and risk ratios are two parameters, measures of association that are very, very widely reported in nutrition research, and that is why I selected them as part of your lecture topic. Okay, so odds ratio, it is the ratio of the odds of an event occurring in the exposed group versus the unexposed group. Concept remains the same. Yep, as I said, that you calculated when you do not know the true incidence. Again, the understanding is the same, odds ratio greater than 1 meaning increase occurrence of that event, less than 1 decrease occurrence of that event, and the formula is also very simple. So when we look at an example, you have 75 people, and then of these 75 people, 20 people have cancer and they are smoking. 55 people have cancer but they are not smoking. Okay, so they have cancer but not smoking. Then you have 60 people who do not have cancer but they are smoking, and who do not have cancer and they are not smoking as well. Okay, you have the formula over here and I have coded this for you, A, B, C, D. So you have cross multiplication, very simple, A into D and B into C, and you get the number 4. Okay, so individuals smoking are 4 times more likely to develop cancer than individuals who do not smoke. Okay, so over here, as I said, can you look at my mistake which I did over here? Should I have used the term times, or should I have used the term odds? The odds of individual developing cancer who are smoking are 4 times more than those who do not smoke. Alright. So this is where I wanted to consciously show you that a lot of papers, they do odds ratio and they report their say their results in times, which is not the best practice. You do odds ratio and you use the words odds in writing your results as well. Alright. You use the words time when you are doing your risk ratio result interpretation and writing. Okay. So yes guys, this is it for yes, your measures of association. We looked at the 2 most important measures of association that you do in the area of nutrition research: risk ratios, attributable risk, and versus your odds ratios. So yes, I hope this has been helpful and I'll see you in the next lecture series. Thank you.